Hi, welcome to Light Utilage. In this session, I will discuss what happens when an element undergoes alpha particle decay. Let me write down here the symbol of alpha particle, alpha, and it is having 4 at the top and 2 at the bottom. The number which is given at the top is considered as mass numbers. It is the mass numbers. And the number which is given at the bottom, it is taken as atomic numbers. Another symbol of alpha particle is represented by helium. It is also having 4 mass numbers and 2 atomic numbers. Now let me take one radioactive element undergoing alpha particle decay. The radioactive element is radium. Here I will mention radium. The symbol of radium is Ra. The mass number of radium is 222 and it is mentioned at the top of that element. And the atomic number that is 88. Here I mention 88. And now this radioactive element is undergoing alpha particle decay. I mention here minus the symbol of alpha particle, that is alpha, and the top is 4 and at the bottom is 2. Remember, when an element undergoes alpha particles, the mass number of that element is reduced by 4 and the atomic number of that element is reduced by 2. Now here we can do the subtraction. 222 is reduced by 4. Now we can do the subtraction over here. 2 is smaller than 4, that's why 1 is taken from 2, it becomes 1 and it becomes 12. 12 minus 4 is equal to 8. Here we have 1 and here we have 2. This is the new mass number is produced, that is 218. Now look at the atomic number of radium elements, that is 88, and 88 is reduced by 2. 88 minus 2 is equal to 86. This is the new atomic number produced in the reaction. Now we have to recognize, identify an element produced in this reaction. We look at the atomic numbers. Atomic number is 86. We look at the periodic table for an element which is having atomic number 86. 86 is the atomic number of radon and its symbol is Rn. This is how we predict a new element formed in the reaction. Let me take the next example. The next example is of uranium. I will mention here the symbol of uranium, and it is having mass number that is 238. 238, and at the bottom it is having that 92. 92 is the atomic number of uranium. Now I will mention alpha particle. It is undergoing alpha particle decay. Here we mention alpha particles. Now we follow the same method, and the mass number of uranium is reduced by 4. We can do the subtraction over here. 238 minus 4. 8 minus 4 is equal to 4. Here we have 3 and it is 234. This is the new mass number produced. And 92 is reduced by 2. 92 minus 2 is equal to 90. This is the new atomic number produced in the reaction. Now we have to look at an element in the periodic table which is having atomic number 90. 90 is the atomic number of thorium and its symbol is Th. Now this is the new element produced due to the decay of alpha particle. Let me take the third example. The third example is of polonium, and the symbol of polonium is Po. I mentioned here Po, and it is having mass number that is 208 and the atomic number that is 84. I mentioned 84. Now it also goes alpha particle decay. I mentioned here helium. We can mention this symbol too, and it is having same mass number and atomic number as this alpha particle. Now we can do the subtraction here. The mass number of polonium is reduced by 4 because it is undergoing alpha particle decay. 208 minus 4 is equal to 204, and 84 is reduced by 2. 84 minus 2 is equal to 82. And so now this is the new atomic number produced in the reaction, and 82 we have to look at the periodic table for an element which is having atomic number that is 82, and 82 is the atomic number of lead element. We mentioned here lead element. Let me take the last example in this session for the decay of alpha particles. The last example is of radons and its symbol is Rn. And so the mass number of radon is 219. I mentioned here 219. And at the bottom the numbers which it has, it is its atomic numbers, and its atomic number is 86. Now it undergoes alpha particle decay. Here I will mention here helium with 4 mass numbers and 2 atomic numbers. Now we can follow the same method. The mass number of radon is reduced by 4. Here we can do the subtraction. 219 minus 4, and 9 minus 4 is equal to 5. Here we have 1 and it is 2. We get 215. I mentioned here 215. This is the new mass number. Now we look at the atomic number of radon, that is 86, and 86 is reduced by 2, and 86 minus 2 is equal to 84. Here I mentioned here 84. And 84, we look at an element which is having 84 atomic numbers, and here you can see that polonium is mentioned here with atomic number 84. It means that the new element which is produced in this reaction, that is polonium. This is how we predict an element formed in a reaction when an element undergoes alpha particle decay. We follow the simple concept. When an element, whether it is a radioactive element or a non-radioactive element, undergoes alpha particle decay, the mass number of that element is reduced by 4, and the atomic number of that element is reduced by 2. Thank you.